Hi there, welcome to Just Another Dev, and today we are going to discuss about the data structures in JavaScript. So if you have been working with JavaScript, you must be knowing that JavaScript does not support most of the data structures out of the box. Unlike other languages like C++, Java, where they have their inbuilt libraries to use the data structures on the fly, there is no such thing provided by JavaScript, apart from the few basic data structures which are like array, object, map, and set. But we can always create them on our own, right? Moreover, there are libraries packages that we can import to use these data structures in our projects. However, you might not be needing them on your day-to-day task in your daily projects, but it is always a better idea to understand how things work under the hood, as many libraries and packages that we use in our projects may be internally using these data structures. We would cover some of the real life use cases when we are going through these data structures so that it can help us understand where and why do we need these data structures and what problem do they solve. So without any further ado, let's get started. And we'll start with the very first data structure, which is basically an object. So as you might have already heard of, in JavaScript, everything is essentially an object. By everything, I mean every non-primitive data type in JavaScript is essentially an object, because if you look at their inheritance chain, if you look at the prototype chain or in any non-primitive data type, it goes back to the top and it meets object, right? So every non-primitive data type inherits from object. Okay, so what basically is an object? So an object is nothing but a collection of key value pairs, and the key is always basically a string or a symbol, and every key is associated with a corresponding value. Now the value can be anything. It can be a string, it can be a number, it can be another array or an object, a function, etc. So we only have a limitation on the key, which has to be a string or a symbol, but the value can be anything, right? So let's see how we can create an object in JavaScript. Creating an object in JavaScript is pretty straightforward. We can just use the object literal. So let's see how we can create a person object here. So we'll just call it a person and then give it a few properties like first name, and let's call it John, last name. And if you notice one thing, I'm not wrapping my keys in double quotes because it is not required if the keys are not containing any hyphen or any other space or anything, right? I can just use them without quotes, but if I have to use any key which is like this, then I'll have to wrap it in a double quotes or a single quote. Then let's give it an age which is maybe 21, and then let's give it a function. So if you remember, I told you that we can have anything in our keys or return something here. Hello from so it will return hello from John Doe. So as you can see, we have all types of what we can say values. So here we have string value, here we have number value, here we have a function value, and what we can do, we can create as many keys as we want over here and put whatever type of values we want. But this is basically the essence, like we can create any type of value over here. The key will always be either a string or a symbol. I'm not covering symbol over here, but you can go ahead and create a symbol key if you want. And yeah, so if you just want to print this object, it will just show it to you that what all things it has. And if you just run this person.create, I do a console.log for this, it should basically give me this message. So let me just run this. Okay, so you see it gave us first name, last name, age, and greet. It's showing as a function over here. And when I ran this person.create, it is giving me hello from John Doe. So this is basically how you can create an object. So this is one of the way of creating an object. There are other ways in JavaScript as well which you can use to create an object. We are not going to cover this because this is essentially a data structures video that we are creating. And next we are going to understand the time complexities while adding or removing a key from an object or updating a key from an object. So let's dive deep into that. So let's talk about the time complexity of objects. So objects have basically a constant time complexity for operations like insert, delete, update or access. The time complexity in this case is constant time complexity, basically O1. You can do it in constant time, but other operations like which involve some iteration, it may be a search operation, or it may be like your object.keys or object.as on property, and operations like these, they consume order of n. Here n basically means the number of keys in the object, right? So insertion, delete, update or access have O of 1, while search or basically whatever is going to take some iteration have O of n. So one thing I would like to add here is that different JavaScript engines implement JavaScript differently. For example, Chrome has V8, Mozilla has SpiderMonkey, and these engines basically take ECMAScript specification and implement in their own way. So it's not necessary that what V8 has implemented should exactly match with what SpiderMonkey has implemented. But one thing for sure is that they will match whatever ECMAScript has specified, right? So this is one thing to basically be aware of, and in most of the cases the insertion, delete, update and access will have constant time complexity or nearly constant time complexity, if not completely O1, and search operations or iteration operations will have O of n, which is basically dependent upon the number of keys. So that's it about object time complexity in JavaScript, and next we are going to cover the arrays. Let's talk about arrays now. So arrays are basically a collection of items which we can store under a single variable name. And in JavaScript, arrays are heterogeneous, which basically means you can store any type of data inside your array. So it doesn't need to be an array of numbers or array of string. It can be a mixed array. Your array can contain string as well as an object, another array, or any item you can provide inside your array item, right? So that's why we mean it is heterogeneous. The next thing is arrays are resizable in nature. What do we mean by resizable? So basically when you create an array in JavaScript, you don't need to specify the size of the array, right? Array can be of any size. It can contain any items from 0 to let's say 100, but you do not need to specify the number of items that you are going to contain in an array. So it can expand and shrink as per the requirement. So that's how arrays are designed in JavaScript. They do not need to use contiguous memory location, and since we do not need to specify the array size at the time of initialization, an array can contain a non-contiguous memory location inside the memory heap. So if we look at this example, let's say we created an array with size of 5 in the beginning, and then say we have to add one more element, right? So when we are going to add that element, it may or may not take up the next memory block that is present, because that may or may not be available. So it might go ahead and take the next available memory block in the memory, right? So when we are going to add an element, it is going to take this memory block. So that's why the array in JavaScript are also called sparse arrays, which is because it is not going to take contiguous memory locations. It may or may not take depending upon how we are creating that array. And array elements are basically accessed from the index 0 to n-1, where n is basically the total number of items in an array, or the length of the array, right? So that's mostly about the arrays, and let's see how we can create them. And creating an array is pretty much straightforward. So let's call it my array, and we can just create it by using this square brackets, and you can put whatever value we want, right? As our arrays in JavaScript are heterogeneous, I can put anything over here. So I put, like, let's say 1, and I'm giving a name like Raj, and I can insert another array as well over here, which can be basically an array of another heterogeneous items or homogeneous items, whatever you want. It can even contain an object as well, which can have any properties. So this is basically how you can create an array, and the operations that we can perform on array are basically like insertion that we checked. So the first insert operation that we can do is push. Push is basically my array dot push, and I can push any value over here. Let's say I want to push 3, and let me just do a console.log my array. So we should be able to see what basically we have just pushed here, right? So if I just do a node array.js, so if you see 3 as well is printed over here, right? So 3 is already inserted over here. Similarly, I can push it at the, or basically insert it at the beginning. So the operation is called unshift. If I do a my array dot unshift, and let's say if I do a unshift of another array which is having a value 2, and I again do this console log, then we should be able to see it in the beginning. So I'll just run it once again. So you can see the first element is now changed to an array element, which is basically containing only one item, 2. So this is about the insertion operations. If you want to access any item in an array, you can do it using the index. So let's say if I want to check the third item in an array, third item in my array, so I'll just do a console log my array 3, and if I just print it, then if I just run this program, I'll get to see this. So the third item is basically 0, 1, 2, 3. Since the array is starting from 0 index, the third item is my fourth element in the array, which becomes 1 and 2, the another array which is basically this. So I'm getting this array printed over here, right? Now let's see the delete operations, or we have two operations. We have two operations here as well, which is basically called pop. So pop basically removes the last item from the array. If I do an my array dot pop, it will remove the last item. So the last item that we added was 3. So after this operation, 3 should be removed from there. I'll just remove these remaining consoles in the meantime. Let me just keep this one so that we can understand what got added and what got removed. Okay, so let me run it again. Okay, so as we can see, we added 3, we printed it, so it had 3, then we added array 2 in the beginning, so that is still there, but here we added the last item, which was basically 3, right? So 3 is not here anymore. Now if I remove the first item as well by using dot shift, then I should be able to see my original array, because what we have done, we added and removed one item from the beginning and the end, right? So the array should remain same as what it was initially. Okay, so if you see here, the array was 1 Raj 1 2 and this object. So here we can see the final array is containing only that, right? So these are the basic operations that we perform in an array. Apart from it, there are many other operations, like you can copy an array, you can concatenate, you can slice. But for our DSA video, we are not going to cover all of them. We are going to look at the time complexity of these operations, which we might be using like very frequently. So let's get to the time complexity part. Now let's talk about the time complexity in an array. So we'll start with the insert operation. So what happens when we want to insert some data into an array? So let's say I want to insert, it's a heterogeneous array that we've already created. We have string, numbers, and an array inside an array, right? So as we talked, with the array in JavaScript can be heterogeneous. Now let's say if you want to add another string into an array, let's call it a test string. So what will happen? A new memory block will be created, and then we are going to insert this string over here, and then the length of the array will increase from 1 2 3 4 5. It will change from 5 to 6. So that's how the insertion will take place. And since we are not going to change any of the existing elements, there is nothing going to change, only one memory allocation will be created, and this will be inserted into that. It will be an O of 1, which is basically a constant time operation. And by insert, I mean actually push in this case. So push has a time complexity of O of 1, but if it was a unshift operation, which is basically adding an element to the beginning, then what will happen? All the indexes that we are having here need to change. So the index is basically 0 1 2 3 4, but if it was a shift operation, let's just create a shift operation. So inside shift operation, what will happen? We'll have to unshift operation, we will have to create a memory allocation over here, and then we are going to push this string, the test string, inside this, which will cause a recomputation of all the indexes, right? Therefore the unshift operation is basically going to take O of n time, which is basically the total number of items in an array. So it is a linear time complexity, while push has a constant time complexity. Same thing goes with the counter operations, which is basically a delete operation. So this was all about insert. Basically we have checked push and unshift. Push has a time complexity of O of 1, while unshift has a time complexity of O of n, because we have to recompute all the indexes. Let's see the time complexity of delete operations, basically pop and shift. So we'll create the array again. I'll just create a very small array just to understand what we are doing here. Let's say it has these items, and we want to remove an item from an array, right? So if we have to remove an item, let's say we are removing it from the end or the pop operation, then this will go away, this memory will be freed, and we don't have to do anything with the indexes, right? So index still remains 0 1 2, only this reference will be removed, the length will change from 4 to 3. But if it was a shift operation, basically removing it from the beginning, then in that case we will have to remove this index, right? And then we'll have to recompute all the indexes, right? So this will become 0, this will become 1, and so on and so forth. So therefore in case of pop, when we are removing it from the end, time complexity remains O of 1, which is basically a constant time complexity, while in case of shift, where we are removing it from the beginning, the time complexity becomes O of n, which is a linear time complexity. So that's how the time complexity differ depending upon where we are adding an element and removing an element. The other operations like search and all will take O of n, because we will have to iterate through all the elements in the array. So if we are doing a search, it will take O of n time, which is again a linear time complexity, because you have to go through all the items and figure out, okay, if this is what you are looking for. The other operations in JavaScript array are like concatenate and splicing, slicing. All of them have to basically go through all the elements. Therefore all of them are O of n in time complexity. Basically whatever is going to involve an iteration of all the elements is going to be O of n time complexity. So that's what we'll have to take care when we are creating a very large array. In a small array, shift and push, you will not see a lot of difference, but if the array grows too big, then these things might show up in your time complexity, right? You will feel that you can calculate that time difference. So you can, if you want, you can create a very huge array and do these operations and see for yourself the time differences between them. So that's mostly about the time complexity. So again, I'll just summarize. Push and pop have O of 1, Then if you are doing a unshift or shift operation, it will have O of n. If you are doing a search, it will have O of n. And also if you are randomly accessing any array element, right, within its range. So if you want to do a let's say array of 1, if you want to check the first item, basically if you are randomly accessing, then it will be O of 1, because you can access array items using their indexes directly, right? So if you do that, then it will be O of 1. So that's about the time complexity of an array, and we have covered the time complexity of both object and array. And in the next video we are going to cover set and map, which are similar to array and object but with a few differences. So we'll cover them in the next video. So stay tuned. Thanks for watching.